Today is 13th February 2026 and it is IGCSE Physics Pressure chapter. And from 2022, it is a very small size chapter in which manometer and hydraulic brakes are excluded from the course. So we have to study only two formulas. Let's start formula number one. And the formula number one is when you exert force on an object, then if you divide this force by the area of surface on which you are exerting force, force divided by area or force per unit area, force divided by area or force per unit area, it is called pressure. Force per unit area, it is called pressure. So it is the basic definition, number one. Number two, its unit. You know the unit of force is Newton. The unit of area is meter square. And usually we measure pressure in Pascal. If you write Newton per meter square, it is also right. But its standard unit is Pascal. So force per unit area, it is called pressure, and its unit is either Newton per meter square or Pascal. Number one. Number two, sir, what is the significance of force per unit area? So the significance is if you keep force constant and if you increase area, then it will reduce pressure. Sometimes we are afraid of high pressure. So, and sometimes we cannot change the magnitude of force, but by increasing area, you can decrease pressure. And sometimes we need high pressure. So if you reduce area, it will increase pressure. So pressure depends upon surface area on which the force is acting. And if we deal an example from the past paper, then obviously it will clear you the concept of pressure. So look at this example. The example is consider there is an ice layer. This is the ice layer, and beneath this ice layer, there is a water reservoir. There is a water reservoir. Consider it is a pond, and a person is standing over this ice layer, and he is feeling the ice layer is breaking. He is feeling the ice layer is breaking. And obviously, if ice layer breaks, then obviously the person will sink into the water. So he is afraid of this breaking of ice. So what should he do? So the solution is given, and the solution is if the person if the person lays down on the ice layer, then it will reduce pressure exerted on the ice layer, and you will see that now the ice layer will not break. And the question is a person moving across an ice covered pond to reach a ball on the ice. Explain why this way of moving across the ice it is safer than walking. It is safer than walking. So what does it mean? You know, if the person is standing on the ice layer, then the whole weight of the person will be on his foot. This is the foot area, and the foot area is very small. The foot area is very small, and if area is small, then there is greater pressure. So if the person walks on the ice layer, then there is a probability of breaking ice layer. But if he lays down, then obviously the surface area in contact with the ice will increase, and increasing the area by moving like this, increasing the area, it will reduce pressure. So the question is again, sir, why this is safer than walking? So the answer is the weight of person is constant. Weight cannot be changed. Weight cannot be changed. The weight of person, weight is a force. The weight of person is constant, but moving like this, the surface area, the surface area in contact, the surface area in contact with ice will increase. And when surface area increase, it reduces pressure. It reduces pressure. So it is safe. Okay. So the situation I have explained, if the person is standing on the ice layer, then his whole weight will be on his foot, and the surface area of foot is very small, so pressure is very high. But when the person is moving like this, then obviously his area in contact with the ice is increased. So when the area is increased, then obviously pressure will reduced. Okay, so we have too many examples, and all the examples we will try to discuss from past paper questions, so it will be easy to explain. So this question is completed, and now I am returning back to the theory. And the theory is, first definition we have completed. Define pressure. Sir, pressure is force per unit area. And what is the significance of this formula? I have explained. And now we have completed this formula. And now describe how pressure varies with force and area. And from everyday example, I will explain you with more examples. And now I am starting the third topic. So what is the third topic? Third topic is, consider this is a container, and in this container, this is filled with a liquid. Consider it is filled with water. Then obviously the weight of the water acting downward, the weight of the water acting downward, and due to the weight of the water, there is a pressure in the base of container. There is pressure in the base of container, and pressure is force per unit area. But in this example, I am writing weight as a force. Okay, number one. Number two, I am driving formula, although this formula derivation is not in your course. Weight is equal to mg, and area is capital A. But if I multiply with depth, I am not writing depth as d because d will confuse with density. So I am writing H, and not only I am writing, it is in your syllabus. It is in your syllabus. The depth of the water is denoted by H. And if I multiply with depth and divide by depth, it is an extra work only to drive formula. Whenever we are driving formula, then we can do any extra work. This is extra work in which I have multiplied and divided by H. And by doing it, you can see, sir, this is mass divided by. Do you know area with depth? It becomes volume. Derivation is not in your course. I am doing extra. Mass remain as it is. Area with depth, it becomes volume. G and depth remain as it is. And now everyone knows, sir, mass per unit volume. Mass per unit volume. Sir, it is called density. Mass per unit volume, it is called density. And the symbol of the density in your syllabus is like this. This is density. And density is not P. This P is written in this form. So it is not P. Actually, the correct alphabet is raw. Actually, this is raw. This is raw. And this raw represents density. So the pressure of a liquid is raw G depth. Note down the second formula of today's class. It is called pressure of liquid. It is called pressure of liquid. So we have completed two formulas. Formula number one, pressure is force per unit area, and its modified form for modified form for liquid, it is raw GH. It is raw GH. Okay. And if you have noted, then we are solving some more questions. Okay, I'm solving some more question, but I need one more thing to explain. And one more thing is, sir, when a liquid is filled in a container, then obviously the weight of the liquid acting downward, and due to the weight of the liquid, there is a pressure. Okay, but you know, there is atmospheric pressure as well. The pressure of air on Earth, our Earth is surrounded by air, and the pressure of air, it is called atmospheric pressure. So if I ask you what is the total pressure at this point, so you should note down this formula. Sir, total pressure is equal to, sir, pressure of liquid plus atmospheric pressure. And you know, pressure of liquid is rho. Rho is the density of liquid. G, G is the gravity. H, sir, H is the depth of the water. Depth means you are measuring distance from the top of the surface. Height means when you are measuring from the bottom, it is called height. And when you are measuring from the top, then it is called depth. So H is the depth. Plus, sir, what is PA? Sir, PA is atmospheric pressure. You know, our Earth is surrounded by air, and the pressure of air, it is called atmospheric pressure. The pressure of air, it is called atmospheric pressure. So it is the final formula, and this chapter will not contain any formula now. There is no more new formula. Only three formulas. Formula number one, force per unit area. Formula number two, rho GH. Formula number three, pressure of liquid plus atmospheric pressure. And now we are solving question. Question number one, June 2021. The question is, sir, there is a bookshelf, and on this bookshelf, there are two groups of books. There are two groups of books, books A and B. Okay, this is group of books A, and this is group B of the books. Okay, so these are two groups of books, and consider both are all books are identical. All books are identical. Okay, and each group contains six books. Okay, all the books are identical. It is also given. The mass of the each book is 0.52 kg. So you are given mass, you are given their length, breadth, height, etc. All these things are given. Now the question is, explain why the pressure exerted on the shelf by the books in group A, sorry, in group B is less The pressure of group B is less. The pressure of group B is less. And the pressure of group A is high. Okay, but there are two groups of book and it is given. Okay, pressure of group B is less and the pressure of books A is high. And you have to explain why. And remember, sir, pressure is force per unit area and force is weight per unit area. And weight of the books are same because the books are identical. Books are identical. It means weight has no effect. Only the key word to explain is area. And now you can see the surface area in contact with the shelf. So this is large area in contact. This is large area in contact with the shelf. And here you can see just by drawing. So the surface area of books in contact with the shelf is small. Here is a small area and here is large area. So where area is large, then obviously pressure will be low. Simple. So I am writing answer. I am writing answer. The surface area of group B in contact with shelf is larger. Surface area is larger. And if surface area is larger, thus the value of pressure will be lower or lesser. Okay. In group B, the surface area in contact with the shelf is larger. When the surface area, this surface area is larger, so less pressure for group B. So I think question is very simple. And now we have to calculate pressure. Beta Rafi? Okay. When we have two group of books, this group A, in this group, sir, books are placed vertically. Books are vertical. हाँ जी 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 pressure is inversely proportional to area. Same force by each book. Same force by each book. Area in contact in group B is greater. Area of group B is greater. So when area is greater, area in contact is greater, so pressure is smaller for group B. Okay. So beta, you can read the marking scheme as well. And if you are finding my answer is not good, then you can write from the marking scheme because I am writing answer from my mind. And if you read the marking scheme, then obviously it will guide you more better. So pressure is inversely proportional to area. The force is same. Only the surface area in contact with the shelf is greater. So the pressure is lesser. Okay. And now we are calculating. So the question is calculate pressure for in group A. We have to calculate pressure in group A. Okay. So, pressure is equal to force per unit area. And I am interested to solve this question here. Sir, pressure is equal to force per unit area. Okay. अच्छा बेटा Manur, I am asking you a question. Manur beta, are you in class? Beta Manur, for calculation of pressure, I need force. What force is acting on the shelf? What is the force which is acting on the shelf? Yes, it is the weight. And you know weight formula is mg. Okay, mg. And what is the mass of each book? Manur, what is the mass of each book? 0.52. But you know there are six books. So it should be multiplied with 6. So it will make total mass. Gravity, you can write 9.8, you can write 10, okay? And divided by area. What area I should write, Manur? What is the base area? Huh? 1.1? Huh? You are right. Yes, you are right. It is a 21 multiply 1.3, but this 1.3 multiplied with 6 because there are 6 books. Okay, this is the thickness of one book. This is the thickness of one book, and there are 6 books. So for 6 books, you should multiply with 6, number one. Number two, sir, all the numbers are given in centimeter. All the numbers are given in centimeter. So we should convert this centimeter into meter. And how do we convert centimeter into meter? So we have two methods of writing centimeter into meter. Method number one is, sir, centimeter is replaced by exponent minus 2. This exponent minus 2 for 21 and this exponent minus 2 for 1.3. Okay, beta, we are given number. So we are converting into force. अच्छा, we are not given any condition. We are not given any condition to convert into meter. We can write answer into Newton per centimeter square. But if you are writing answer Pascal, then length must be in meter. ठीक है बेटा राफे? If you are writing answer in Newton per centimeter square, it is also acceptable because we are not given any unit. We are not given any unit. Newton per centimeter, it is also right. But if you look at the marking scheme, in the marking scheme, they are writing answer in Pascal. Okay, they are writing in answer in Pascal. So Pascal is better, but you can see in centimeter square, it is also acceptable. Okay, but both are correct. But I am converting into meter. So this is 21 centimeter. So I wrote exponent minus 2. This is 1.3 centimeter. So I wrote exponent minus 2. So this centimeter converted into meter. And there are 6 books. So I have multiplied with 6. So the final answer is, sir, this is mass 0.52 for 6 books. Gravity is 9.8. And it is quite interesting. This 6 cancel out with this 6. Okay, so you can cancel out 6 as well. So the total mass is multiplied with 6 in denominator 21 into 1.3, but there are 6 books, so it is multiplied with 6. And now if you solve by calculator, then I think answer will be 1900. Jibda, you can check. Nevia, you can check. Is it 1900 Pascal? Okay, it is 1900 Pascal. This is 1900 Pascal. Okay, so this question is completed. This question is completed. And now, sir, we have the next question from pressure of liquid. We have a next question from pressure of liquid, and we have no space to solve this question. No, no, sir, we can solve. We can solve. We can solve here. Okay, what is the question, sir? The question is, sir, a diver dives, a diver dives into a depth below the surface of seawater where total pressure is given. Total pressure is given. Okay, beta. Sir, when we are given total pressure, then you know total pressure is equal to pressure of liquid plus atmospheric pressure. Okay, but we are given total pressure, and total pressure is equal to pressure of liquid plus atmospheric pressure. Okay, and now I am putting the values in this equation. Sir, total pressure is 3 exponent 5 is equal to pressure of liquid. Sir, pressure of liquid is rho. Rho means density. G depth. And you know we have to calculate depth. We have to calculate depth. Okay. So H is the depth plus atmospheric pressure. Sir, we are given atmospheric pressure. Atmospheric pressure is 1 exponent 5. So this is total pressure. Sir, total pressure is 3 exponent 5. Total pressure is 3 exponent 5. Pressure of liquid, sir, rho GH. Atmospheric pressure, it is given 1 exponent 5. And now I am shifting this number on the other side. I am shifting this number on the other side, which is 1 exponent 5. Okay, so it is in plus, it will be converted into minus, but I'm solving here. So 3 exponent 5 minus 1 exponent 5 is equal to rho. So rho is the density, and the density of seawater is also given. So it is 1030. Density of seawater is given, it is 1030. Into gravity, sir, gravity is 9.8. And sir, we have to calculate depth. Sir, we have to calculate depth. Okay. And now I am solving. Sir, 3 minus 1, it becomes 2 exponent 5 divided by 1030 into 9.8. And if you solve it, then what is the depth, beta? It is 19.8. But I think Mahanur microphone is not muted. राफे microphone is not muted. क्या हो गया राफे भाई? राफे, okay. अच्छा जी. Sir, in this question, sir, this is total pressure minus atmospheric pressure is equal to density, gravity, depth, and by algebra you have calculated H. Okay, so this question is totally completed. June 2021. And now we have another question. It is June 2020 question. The question is a scientist fills a container with seawater. The container dimension 30 by 30 by 40. Okay. You are given density. Calculate mass. You know, mass per unit volume is equal to density. And now you should write density by this symbol. Okay. Sir, mass per unit volume, it is equal to density. And if you are calculating mass, then mass is equals to density into volume. And now I am putting the values. Sir, mass is equal to density. Density is 1020. And now volume. Now volume. You know, volume, all the dimensions are in centimeter. So I am converting into meter. I am converting into meter. 30 centimeter is 0.30. So it is divided by 100. It is divided by 100. It is divided by 100. Sir, why did you convert into meter? So the answer is that density is in meter cube. When density is in meter cube, then volume should also be in meter cube. So all centimeters are converted into meters. And now, beta Navia, can you answer me what is the mass of the water? 36.7 kg. Okay, and all the given numbers are in maximum in 2SF. So it should be rounded up to 37 kg. 37 kg, yes. The answer is 37 kg. So we should convert into 2SF, and in 2SF it is equal to 37 kg. All the given numbers are in 2SF, 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 2SF. So the final answer should also be in 2SF. So first we have calculated mass, and now the question is, there is a submarine, and this submarine is fully submerged in the sea. The submarine is fully submerged in the sea. Okay. And the atmospheric pressure is 100 kilopascal. The total pressure is 500 kilopascal. Calculate depth. Sir, it is again same kind question. Sir, total pressure is equal to pressure of liquid plus atmospheric pressure. And obviously, total pressure minus atmospheric pressure is equal to pressure of liquid. So whenever you are given total pressure, then you should subtract atmospheric pressure. So total pressure is 500, atmospheric pressure is 100, and both are in kilopascal. Both are in kilopascal. So kilo should be replaced by 1000. 500 beta total pressure, 100 atmospheric pressure, 500 minus 100, it becomes 400, and kilo is replaced by 1000. On the other side, sir, density of seawater, we are given in the first part of the question, it is 1020. Density is 1020. Gravity is at 9.8. Sir, we are calculating depth. So finally, depth equals to depth equals to sir 500 minus 100. It becomes 400. Kilo is replaced by 1000 divided by 1020 into 9.8. And Ammar bhai told me answer which I have missed. जी अमर भाई क्या था आंसर 40. So the depth of the water is 39 meter here. ठीक है जनाब, and I think they used gravity 10. Okay, but they used gravity 10, but right now we are using gravity 9.8. So if your answer is according to 9.8, then it is better. You should use gravity 9.8. Okay, but now it is instructed to use gravity 9.8. And now we have calculated depth. And after calculating depth, sir, we are given, okay, this is submarine, this is submarine, and there is a door of submarine. Sorry. This is the door. This is the door of submarine, and this is called hatch. Okay, so this is the hatch, and it is on the top surface of the submarine, and you are given its area. You are given its area. The question is calculate force. Calculate force on the hatch. Calculate force on the hatch due to total pressure. Due to total pressure. Sir, force per unit area is pressure. Force per unit area is pressure. Sir, if you are calculating force, then force equal to pressure into area. Then force is equal to pressure into area. The total pressure, because it is given, use total pressure. Sir, total pressure is 500 kilopascal. Total pressure is 500 kilopascal, and it is multiplied with area. Area of H, it is 0.62. Area of H, it is 0.62. But Ammar, I think you are in form. You are in very good form. Then if you multiply all these numbers, then what is the total force? What is the total force? The total force, it is 310 kilonewton. Is it right, beta? In the marking scheme, the answer is 310 kilonewton. Kilo means answer will be 310,000. So three zeros are replaced by kilonewton. Three zeros are replaced by kilonewton. If you do not use thousand, then this thousand will be converted into kilo. Okay, this question is completed, and now we are solving another question. Another question. The question is, sir, it is a swimming pool, and the depth of the swimming pool is missing. So in the marking scheme, I noted the depth is 0.3. Okay. And this is filled with water. It is filled with seawater. And it is the top. जी बेटा बेटा एक्सप्लेनेशन में प्रेशर का फॉर्मूला यूज हो रहा है फोर्स पर यूनिट एरिया बेटा इसके अलावा तो आपको आ ही नहीं रहा है इसमें जी 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 ओके बेटा एंड नाउ the question is it is filled with water and the mass of the sea water is 2.7 exponent 5. Calculate density of the water. Okay, sir, we have to calculate density of the water. Sir, what is the formula to calculate density? Sir, density is mass per unit volume, mass per unit volume, and depth is given, it is 0.3. But Amna, can you help me to solve this question, Amna? Can you unmute yourself? Amna, beta, can you unmute yourself? Beta, Amna, what is the mass of the seawater? Amna, beta, what is the mass? Yes, it is the mass. And now we have to calculate volume. How do you calculate volume of the swimming pool? What is the volume? जी बेटा, what is the volume? Hmm. Hmm. It is area. And I am asking you volume. And volume is length into breadth into depth. Okay. And as I told you, the depth is 0.3. ठीक है बेटा? It is 0.3. So length into breadth into depth, it will give you volume and mass divided by volume. Mass divided by volume, it will give you density. And the density should be 1020. 1020. If you calculate from calculator, then answer is 1020. Mass is in kilogram, volume is in meter cube. So the density is 1020 kg per meter cube. So we are given mass, we are given volume. So we have calculated density, and after calculated density, now the next question is calculate pressure. But Manur, can you tell me how do you calculate pressure of liquid? What is the formula to calculate pressure of liquid, Manur? What is formula to calculate pressure of seawater? Yes, yes. So the density we have calculated, it is 1020. This is density. Gravity, we are using 9.8. Depth, sir, depth is missing in the question. It is 0.3. Okay. And if you multiply these numbers, then obviously you can calculate pressure. And pressure should be around 3100. And the unit of pressure is Pascal. जी बेटा, note down this pressure calculation. Sir, pressure is rho gh Rho is the density, G is gravity, depth is 0.3. जो आ रहा है बेटा वो लिख लीजिए बिकॉज वी आर यूजिंग 9.8 एंड इन द ओल्ड मार्किंग स्कीम दे आर वर्किंग ऑन 10. ठीक है बेटा, जो आपका रिजल्ट आ रहा है वो आप लिखिए. अच्छा बेटा, नाउ द लास्ट पार्ट, स्टेट अ सुटेबल इंस्ट्रूमेंट फॉर मेजरिंग लेंथ एंड breadth. Sir, length and breadth are too large, 20 meter, 44 meter. Okay. So we cannot measure by micrometer, by vernier caliper, by meter rule. We cannot use. And if we have to measure such large length, then we should use measuring tape. बता माइक्रोफोन बंद कर लीजिए. We should use measuring tape. We should use measuring tape. So this question is also completed. And now another question. So in this question, the depth of the water is 2 meter, and now you have to calculate volume of the water. Only calculate volume of the water. But here, can you help me to calculate volume of this tank in which depth is also given? Ji beta, here can you help me? And this swimming pool should be divided into two sections. Beta, here, what is the area? What is the area of green part? Not plus, it should be multiplied beta, because we are not calculating perimeter, we are calculating area, and area is the product. Okay beta, area is the product. If you add them, it will be perimeter. Okay, so 1.6 into 1.1, you are right, it is the area of this green part. Ji beta, then what is the area of red part beta here? Yes, 1.0 multiply 3.2, okay, and it is the area. And now the whole area is multiplied with depth. Whole area multiplied with the depth. And the depth of the tank is 2 meter. So area is multiplied with depth. Depth is 2 meter. Okay, now calculate beta here by calculator. If you have calculator in your hand, then can you tell me what is the volume? 11.264, but the marking scheme saying it is around 9.9. इतना बड़ा डिफरेंस क्यों आ रहा है भाई? कैलकुलेटर चलाने में गलती है. 8.16 भी चल जाएगा. ठीक है, लेकिन 8.16 भी बहुत दूर है 9.9 से. आपका आ रहा है 9.92, नेविया का भी आ रहा है 9.92. बेटा हीर में आपको कैलकुलेटर चला के दिखाऊं या आप एक दफा और खुद से ट्राई कर लीजिए बेटा. अगर वो जब डेप्थ से मल्टीप्लाई करोगे तो मीटर क्यूब में खुद ही कन्वर्ट हो जाएगा. देखिएगा बेटा, मैं आपके सामने कर रहा हूँ. ब्रैकेट 1.6 इंटू 1.1 ब्रैकेट क्लोज प्लस 1 into 3.2, obviously it makes 3.2. So the answer is 4.96. So 4.96 is area. And then 4.96 will be multiplied with 2. So it is multiplied with 2. Then the answer is 9.92. Beta, here is it clear or not abhi? ठीक है जी. So this is the volume. This is the volume of the water. And now as we have calculated volume, sir, we are given density and they are asking to calculate mass of the water. So mass is equals to density into volume. So density is 1.1 and volume, sir, we have calculated 9.92. Then their product, it will give you mass. And mass should be equal to 1.1 exponent 4. 1.1 exponent 4. So this is the mass. 1.1 exponent 4. Okay. And now the last part, calculate pressure due to water. Calculate pressure due to water at a depth of this. At the depth of the this. ठीक है जी? So we are calculating pressure due to water at a level of 0.8 meter above the base of the tank. Okay, okay, okay. Actually, this is not a depth. But Rafid, in this question, they are making confusion. Can you tell me what is 0.8? Is it depth or not? क्लास में ही नहीं है. अरे चलो, Mark, can you tell me what is this 0.8? If you read the line carefully. If you read the line carefully, then is it depth? Height होगी. Yes. Actually, the total depth of the water is 2 meter. Okay, beta. The total depth of the water is 2 meter. 2 meter is the depth. And this 0.8 meter from the base. 0.8 meter from the base. So this is 0.8 meter. And to calculate pressure, because you know pressure is rho GH. Pressure equation is rho GH. So density is 1.1 exponent 3. Gravity, we are using 9.8. So our answer will be little bit different from marking scheme. But the issue is, sir, what is H? H will neither be 2 meter nor be 0.8 meter because depth is this number. And this number is, sir, total depth minus 0.8. Yes, it is 1.2. This is 1.2. The depth, you know, depth is measured from the top. Depth is measured from the top. If you are measuring depth from the top, then it will be 2 minus 0.8. Okay, but now if you multiply all these numbers, then the answer is 1.3 exponent 4 Pascal. The answer will be 1.3 exponent 4 Pascal. Okay, beta. So in this question, and they used gravity 10, and nowadays we are using gravity 9.8. So your answer may be different. Okay, so the key word or key point in this question is, sir, the depth is neither 2 meter and nor it is 0.8 meter. Sir, we will subtract 2 minus 0.8. It is 1.8 and it is 1.8 depth from the surface of the liquid. And now the last question of today's class. So the question is June 2023, paper 42. First part we have already solved, and second part we are going to solve. And this second part I am going to solve, but I am stopping recording